So let's start chemistry paper 1 multiple choice, October-November 2023, variance 11. The duration of this paper is 1 hour. You will get 40 questions in the paper and you need to attempt all of them. All right. Total mark for this paper is 40. You will get the periodic table in the question paper, but you will not get the qualitative analysis notes, which means you need to prepare cations and anions identification, solubility and test for gases, and flame test for different metals. All right. So you need to prepare this stuff. Let's see what we have in this paper. Let's talk about question number 1. In which changes do the particles move further apart? Particles move further apart. That means the space between the molecules increases. And if the space between the molecules increases, then it means distance between the molecules also increases. All right. So in the first option, a gas is heated from 0 degrees Celsius to 25 degrees Celsius. And that's the right option, because when you increase the temperature, kinetic energy increases. Kinetic energy increases, movement of the gaseous molecule increases. If movement of the gaseous molecule increases, obviously the molecules will move further away from each other, which means the space between the molecules increases. So that's what we have done in the states of matter chapter. All right. So first statement is fine. Next, pressure is applied to a gas at constant temperature. When pressure is applied, the gaseous molecules are compressed. When gaseous molecules are compressed, the space between the gaseous molecules decreases, whereas examiner wants the space between the molecules increases, which means second statement is incorrect. Third, steam condenses to form water. If the steam condenses to form water, then it means technically gas is converted into liquid. If gas is converted into liquid, then it means the space between the molecules decreases. And again, this is going to be incorrect. Let's talk about the fourth statement. Water evaporates at room temperature. Obviously, water at RTP, when evaporates, it changes its state from liquid to gas or liquid to vapor. And obviously, when it will turn into vapor through evaporation, the gaseous molecules are, the space between the gaseous molecules obviously increases, and therefore fourth statement is also correct. So 1 and 4th statement is correct, and therefore B is going to be the right answer. Okay. Question number 2. Data about 2 compounds is given. Both compounds have a simple molecular structure. If compound have a simple molecular structure, then it means compound must have covalent bonding. Because all covalent molecules exhibit simple molecular structure. That's what we have done in the bonding chapter. All right. Now we have 2, H2S and PCl3. All right. 2 bottles are placed close together inside a large container at a temperature of 90 degrees Celsius. One bottle contains 1 gram of H2S. The other bottle contains 1 gram of PCl3, which means both have same masses. A detector is placed in the container 2 meters away from the 2 bottles. The 2 bottles are opened at the same time. That means examiner is talking about the diffusion. Which row is correct? Compound that reaches detector first. And that's talk about the diffusion thing, right? Diffusion depends on molecular mass. Take out the MR of H2S. Sulfur is 32. Hydrogen is 1 times 2 because we have 2 hydrogen. So it's going to be 34. MR of PCl3. Phosphorus is 31. Plus chlorine is 35.5 into 3. So let me calculate. 35.3 plus 31 is going to be 137.5. All right, which means H2S has a lower MR and therefore it has greater rate of diffusion. If it has greater rate of diffusion, it reaches first at the detector. Let me check what sort of options we have given. Compound that reaches detector first, obviously H2S. Now, explanation is gases diffuses faster than liquids. That's not all the time because different gases have different rate of diffusion. For instance, when we talk about carbon monoxide, it has a lower diffusion rate, whereas when we talk about carbon monoxide, it's a higher diffusion rate. So gases have different rate of diffusion. It's not the case all the time. All right. So first statement is incorrect, and therefore option A is incorrect. Now the next is H2S has a lower MR than PCl3. That's what we have done here. HCS has a lower mass, and so it has a higher rate of diffusion, and therefore I believe B is going to be the right answer. Okay. Substances can be elements, compounds, or mixture. Which is correct? Element. Element could be element could be copper, nitrogen, and oxygen. Methane is a molecule, right? So we cannot consider it as an element. Compound. Compound is basically glucose, carbon dioxide. Okay. Brass is an alloy, it is not in compound. Carbon is an element. So obviously, I must say that A and B options are incorrect because these two options are incorrect. Okay. Now, mixture. Zinc is or not a mixture. Petroleum is a mixture of different products. Water vapor is not the mixture. Air is a mixture of different gases. So I believe D is going to be the right answer. Okay. Question number 4. The letters X, Y, and Z represents different atoms. Okay. Look at these atoms. These two atoms have same atomic number, which means both of them have same, which means both of them are same elements. But as they have different nucleon number, which means both of them are isotopes of each other also. Because isotopes have same number of protons, but different number of protons and electrons, but different number of neutrons. In other words, we can say that isotopes have same atomic number, but different mass number, which means both of them are isotopes of the same element. So let's talk about which statement is correct. X and Y are the same element. That could be the right answer. But let's talk about other options also. X and Z are the same elements. That's not even possible because both of them have different atomic numbers. So option B is incorrect. X has more protons than Y. Since the proton number in both the cases are same, which means they have same number of protons. So not more, same. So obviously C is also incorrect. Z has more neutron than Y. Y. 39 minus 19 becomes 20. (39 minus 19 becomes 20. So it has 20 neutrons. Let's talk about Z. 40 minus 20 is basically 20 neutrons, which means both of them have same number of neutrons. So obviously D also incorrect, and therefore A is going to be the right answer. Okay. Question number 5. A student makes 3 statements. Calcium ions have 2 plus charge. That's absolutely correct because calcium found in group 2 of the periodic table, and all group 2 elements have 2 electrons in the valence shell, which is why calcium has 2 plus charge. And oxide ion has a 2 minus charge. And obviously oxide has a 2 minus charge. That's also correct. Okay, because oxygen belongs to group 16, belongs to group 6, and so it has 6 valence electrons. So to complete its octet, it will gain 2 electrons. And when it gains 2 electrons, obviously it will carry 2 minus charge. So first statement is going to be right. Next, magnesium ion and oxide ion have same electronic configuration as neon. That's absolutely correct. That's what we have done in the class also. See, this is your oxide ion. Oxygen has an atomic number of 8. That means it has 8 protons. It needs to be 8 electrons, but the 2 minus charge means it absorbs 2 electrons. So total electrons would be 10. And obviously 8 neutrons because it has a nucleon number of 16, right? Let's talk about magnesium ion. It has atomic number of 12, which means it has 12 protons. 2 plus charge means 2 electrons are lost from the valence shell, so it has 10 electrons now. It has a nucleon number of 24, which means it has 12 neutrons, right? So look, oxygen and magnesium ion has same number of electrons, that is 10. Neon has an atomic number of 10, which means it has 10 protons and 10 electrons, which means neon and these two ions have same number of electrons. The second statement is also correct. Okay. Calcium ion have 3 full electron shells. That's also correct. Calcium ion. Let's talk about calcium ion. The atomic number of calcium ion is 20. It has 2 plus charge, which means total electrons is 18, right? So first shell contain 2, second shell contain 8, third shell contain also 8. So this is full electron shells. So first statement is right. And magnesium ion have 2 full electron shells. That is also right. Because when we talk about magnesium ion, you have total 10 electrons. So first shell contain 2, second shell contain 8. That's also correct. So right answer is going to be Na. All right. Question number 6. Force elements about graphite, diamond, and silicon 4 oxide are listed. Diamond and silicon 4 oxide are both very hard. That's right. And have similar structure. That's also right. That's what we have done in the last class also. Yesterday, we were solving the paper and the same concept came in the paper, right? So we were told, so I've told you that both diamond and silicon dioxide have tetrahedral structure or tetrahedral arrangement, all right? So first statement is right. In diamond, each carbon atom is joined to 4 other carbon atoms. That's also correct. This is the structure I have given you in the class. If you remember, that was the structure, right? So this is carbon atom, this is carbon atom, this is carbon atom. So this carbon is surrounded by 4 neighbor carbon atoms. So second statement is also right. Now the next is silicon 4 oxide forms a giant structure of silicon and oxygen atom. That's also correct. Silicon has a giant structure between silicon and oxygen, like this. Now, is diamond and graphite both conducts electricity? That's this wrong statement because diamond cannot, while graphite cannot both. Okay. So fourth statement is incorrect, and therefore A is going to be the right answer because 1, 2, and 3 statements are fine and correct. Which row is correct? Compound. Okay. All of them are compound. Ammonia is a gas, ammonia is a molecule, and its formula is actually incorrect, which is why option A is incorrect. Ethene has incorrect formula, which is why B option is incorrect. Methanol, the formula of methanol is CH3OH. So it has 1 carbon, it has 4 hydrogen, and it has 1 oxygen. So methanol, so that can be possible. That can be possible. So C is going to be the right answer. Propanic acid. Propanic acid, the structure of propanic acid is this: CH3, CH2, COOH. We have done this in class, all right? So you guys need to remember all these structures and their formulas. And I've given you the molecular formula of propanic acid as well. You can even check the register. 1, 2, 3 carbon atom. We have 6 hydrogen atoms and we have 2 oxygen atoms. whereas it has 8 hydrogen atom, which is not possible. Therefore, option D is also incorrect. Hence, C is going to be the correct answer. Let's move on to the question number 8. Compound Y is the only substance formed when 500 cm cube of ammonia reacts with 250 cm cube of carbon dioxide. All measurements are at RDP. 500 cm cube of ammonia. Okay. So divided by 24,000 cm cube. So I'll get the moles of ammonia from here. 500 divided by 24,000. So it's going to be 0.0208 moles. Okay. And carbon dioxide. Let's talk about the moles of carbon dioxide. We have 250 cm cube divided by 24,000. So I'll get how much? 250 divided by 24,000. So I'll get 0.0104. 0.0104 moles. Okay. Now what we can do is that we have ammonia and we have carbon dioxide. Take out the simplest ratio by dividing the least value. That's what we have done in the empirical formula. All right. So 0.0104 would be the least value. So it's going to be 1. And 0.0104. So it's going to be 2, which means we have 2 ammonia molecules. We have 2 ammonia molecules and we have 1 mole of carbon dioxide. All right. If you combine these 2 molecules, you will get how many nitrogens? 2. How many hydrogens? 6. 1 carbon and 2 oxygen. That's the molecular formula. All right. So let me check which option has the same molecular formula. This is N2H8. So we have this option is incorrect because we have 8 hydrogen atom, whereas we have 6 here, right? Now in B, we have 2 nitrogen atoms. We have 6 hydrogen atoms. We have 1 carbon and we have 2 oxygen. So that's the molecular formula and that is going to be the right answer. Okay. I hope it makes sense to you. Question number 9. How many sodium ions are there in 30 grams of sodium sulfate? First of all, take out the moles of sodium sulfate. (30 divided by MR of sodium sulfate. Now get the MR by using the periodic table. Sodium has an AR of 23 times 2 because we have 2 sodium in the formula, plus 32 of sulfur, plus 16 times 4 is going to be 142. So 30 divided by answer is going to be 0.211 moles. Examiner is looking for sodium ions. All right. So sodium sulfate, if ionizes, gives you 2 sodium ions and a sulfate ions. According to the equation, we have 1:2 ratio. If we have 0.211 moles here, how much amount of sodium ions? So basically what we do is we need to do it multiply by 2. So it's going to be 0.4225 moles. Oh my goodness. I'm running out of space. So let me solve this. 1 mole equals to 6.02 times 10 to the power 23 ions or particles. So if we have 0.4225 moles, how much particles or ions we have? So into 6.02 exponent 23. So it's going to be 2.4 into 10 to the power 23. That's my answer. So that's incorrect, and that's the correct one. Okay. Question number 10. 3 compounds are listed: copper 2 nitrate, zinc sulfate, sodium thiosulfate. That was the reducing agent, by the way. Which row shows the element that is present in the greatest percentage by mass of in each compound? The MR of compound is already given, so we need to compare copper and oxygen in copper nitrate. That's tough again. That's a lot of calculation, guys. Yes. Percentage by mass of copper. So the AR of copper is 64, 63 or 64. Let me check. I'm confused between 63.5 and 64. Copper is 64. All right. 64 into 1, because we have 1 copper in the formula, divided by MR, which is 188, into 100. So percentage is going to be 64 divided by 188 into 100 is going to be 34.04%. Similarly, we need to find the percentage by mass of oxygen in copper nitrate. So we have 16, AR of oxygen is 16. We have 6 oxygen atom. How come? 3 times 2 is 6. So into 6 divided by 188 into 100. So 16 times 6 divided by 188 into 100 is going to be 51.06%, which means oxygen. And that indicates option A and B's are incorrect. All right. Zinc sulfate. Oh my goodness. Zinc sulfate. Okay. Let me change the color. Percentage by mass of zinc. So zinc has a mass of 65 into 1, because we have 1 zinc atom in the formula, divided by the MR, which is 161 into 100. So it's basically how much? 65 divided by 161 into 100 is going to be 40.3%. Now, percentage by mass of oxygen in this scenario. So oxygen has a mass of 16, because this mass is given in the formula. We have 4 oxygen atoms in the formula, so it needs to multiply by 4 divided by 161 into 100. So formula is going to be 16 times 4 divided by 161 into 100 is going to be 39.75%, which means in zinc sulfate, zinc has a greater percentage by mass. So obviously I'm gonna go for these 2 options. All right. Thiosulfate, sodium thiosulfate. My goodness. And we need to find oxygen, sulfur, and sodium. My goodness. So I know that A and B are options are incorrect. So let me find sodium and sulfur percentage so that I can decide my option, right? Let me take another color. Percentage by mass of sodium in sodium thiosulfate. The AR of sodium is 23. We have 2 sodium atom in the formula, so into 2 divided by MR, which is 158 into 100. So it's basically 23 times 2 divided by 158 into 100 is going to be 29.1. Okay. Now let's get the percentage by mass of sulfur. Sulfur has an AR of 32. We have 2 sulfur in the formula, so into 2 divided by MR, which is 158 into 100. So 32 times 2 divided by 158 into 100 is going to be 40.5. So 40.5 is the greatest percentage by mass of sulfur. So sulfur, right? The right answer is going to be D. I hope it makes sense to you. Okay. The complete combustion of 20 cm cube of a gaseous alkane requires 130 cm cube of oxygen. Both volumes are measured at RTP. What could be the identity of X? That's called trial and error method. I mean, you need to apply the concept on option A. If you get 130 cm cube of oxygen, that means your right answer. If you won't get the answer, obviously you need to try for B, and so on, right? So it's a trial and error method in which you need to try all the options. Option which will give you 130 cm cube of oxygen is going to be the correct one. All right. So let's talk about first. Let me give you option A, butane. Butane has a molecular formula of C4H10. If it combusts in the presence of oxygen, obviously it will give you carbon dioxide and water. Let's balance the oxygen atom. We have 6 oxygen here. We have 5. So, 4 times 2 is 8. 8 plus 5 is 4 times 2, 8. 8 plus 5, 13. 13 oxygen we have. So 13 divided by 2 is going to be 6.5. That means it has to be 6.5 oxygen, right? So we have total 13 oxygen here. So to make 13 oxygen, we need to use 6.5 into 2. All right. So let's talk about the first option here. We have 20 cm cube of butane. So 20 divided by 24,000. Why 24,000? Because examiner is talking about RTP. So I'll get the moles of C4H10. 20 divided by 24,000. I'll get 8.33 into 10 to the power minus 4 moles. Okay. Now in the second step, C4H10 and oxygen has 1:6.5 ratio. If you have 8.33 into 10 to the power minus 4 moles, how about the moles of oxygen in this way? Obviously into 6.5, I'll get what? 5.41 into 10 to the power minus 3 moles. Now I'll get the volume by using the moles. The volume of oxygen is basically moles, which is 5.41 into 10 to the power minus 3 into 24,000 cm cube into 24,000 cm cube. So it's going to be 130 cm cube, right? And the same volume is already given in the question, which means A is going to be the right answer. Okay. Okay. Question number 12. Aqueous copper 2 sulfate is electrolyzed with copper electrodes. See, copper electrodes. What is the equation for the reaction occurring at anode? Since anode is made up of copper and at anode oxidation takes place, which means copper is oxidized into copper ions and electrons. So A is going to be the right answer. 3 elements about fuel cells are given. A hydrogen oxygen fuel cell requires a continuous input of fuel and oxygen. That's correct. All right, that's correct. In a hydrogen oxygen fuel cell, hydrogen is burnt in oxygen to produce electricity. That's absolutely incorrect. Because if you remember, I have given you the lecture. I've told you that hydrogen is reacted with hydroxide ions. All right. During the production of electricity, hydrogen is reacted with hydroxide ions. All right. Whereas oxygen reacts with water. To give hydroxide ions. That was the whole concept. That was the whole concept behind that. So oxygen reacts with water to give hydroxide ions, whereas oxygen is reacted with hydroxide ions. So during the production of electricity, these two reactions were happening in the system, right? So that means second statement is absolutely incorrect. Second statement is absolutely incorrect. Second statement is incorrect because hydrogen uh, is burnt in oxygen to produce electricity. Technically, it's not happening. When a hydrogen oxygen fuel cell is operating, water is the only chemical product. That's the right statement, because after cancelling all hydroxide ions and water, you will get the final product like this: 2H2 gas plus O2 gas converting into 2H2O. So third statement is right. So 1 and 3 options are correct, and therefore C is going to be the right answer. You have to be very, very careful in a very minor information given in the notes, right? So you guys should know the every minor detail of your lecture, so that you can have an idea in such questions whether it is correct or not. All right. Technically, everybody knows that hydrogen and oxygen reacting together, converting into steam, because that was the overall equation. So everybody thought that this going to be the correct option, but technically it's not, because during the production of electricity, these two reactions were happening at the respective electrode. So if you have got the wrong option, if you have got this wrong option, obviously you need to revise the lecture. Okay, you need to go through the notes again. That's your weak area then. Means under certain conditions, nitrogen reacts with oxygen to form N2O. All right, the reaction pathway diagram is shown. This reaction pathway diagram indicates that the reaction is endothermic because the energy of product is greater than that of reactant. Also, delta H value is positive. All right, this is the activation energy. This is enthalpy change. Examiner is asking activation energy for the reverse reaction. So reverse reaction is basically exothermic. In exothermic, the energy of product is less than that of the reactant, right? For exothermic reaction, we need to consider this threshold. All right. So what we can do is we have 447. So we need, and since the reaction is reverse, so this positive is going to be negative. So it's going to be how much? 447 minus 167, or minus 164, sorry, minus 164 is going to be 283 plus 283 kilojoules per mole. The right answer is going to be D. Okay. So if you remember one thing, forward reaction is endothermic, so the sign is positive. So if the reaction is reverse, then it means it is going to be exothermic. If it is going to be exothermic, then obviously it's going to be converted into minus 164 kilojoules per mole, right? So you need to subtract these two values in order to get the activation energy for the reverse reaction. That's what I did in the question. Question number 15. Hydrogen and bromine reacts to form hydrogen bromide. Bond energy data is given in the table. What is the enthalpy change delta H for this reaction? Okay, that's a very simple sort of calculation. Delta H equals to bond energy of reactant minus bond energy of product. That's the formula. Reactants, we have hydrogen and bromine. Hydrogen has a bond energy of 436. Bromine has a bond energy of 193 minus product. Product is HBr, which is 366 into 2. So delta H is going to be how much? 436 plus 193 minus 366 plus, or 366 times 2. Hold on. So it's basically minus 103 kilojoules per mole. So I believe B is going to be the right answer. Okay. That's a very simple question, guys. 16. Octane is an alkane which has a formula of C8H18 and it is a hydrocarbon. And obviously it is going to be the saturated hydrocarbon because it is an alkane. Okay. When octane is mixed with an excess of oxygen, obviously combustion reaction takes place. And when combustion occurs, obviously you will get two products, water and carbon dioxide. And lots of energy is also given off, right? No change takes place unless energy is supplied. If energy is supplied in the form of heat or an electric spark, a change takes place quickly. And that change is basically the chemical reaction. And during the combustion reaction, we'll get either carbon dioxide or water. The product of this change include carbon dioxide. All right, which part of this description shows that the change is a chemical reaction? Obviously, carbon dioxide is the product. So octane is a hydrocarbon, that's fine, but it has nothing to do with the chemical change. So obviously, option A is incorrect. No change takes place unless energy is supplied. Again, it has nothing to do with the chemical change. The change takes place quickly when energy is supplied and or an electric spark. So I'm looking for a chemical change in which new products are formed, right? New change takes place or new products are formed. And I think, and I'm sure D is going to be the right answer because carbon dioxide is the product. Okay. Question number 17. A student plans to investigate how the rate of reaction changes when hydrochloric acid and calcium carbonate react. We have done this experiment in the class, all right? If you remember, 3 methods are described. Record the mass of flask and content every 30 seconds for 5 minutes. So, yes, within this span of time, I can record the change in mass of the flask and content. And so that I can find the rate of reaction. So record change in mass of flask plus content every 30 seconds. Okay? So that will give you the rate of reaction. Okay. Now in the second experiment, measure and record the volume of gas in the syringe after 30 seconds. Actually, in 30 seconds, reaction is going to finish. Reaction is not going to finish. So within this short time, we cannot collect volume of carbon dioxide. So we cannot collect the total volume of carbon dioxide in the gas range, which means in this shortest span of time, we cannot find the rate of reaction. And so second option is incorrect. Third, again, within 5 minutes and for every 30 seconds, I can count and record the total number of bubbles of gas and so that I can find the rate of reaction. So 1 and 3 are basically the methods through which I can find the rate of reaction. So 1 and 3. So right answer is going to be C. 18. Aqueous bromine is an equilibrium. Aqueous bromine is an equilibrium mixture. Aqueous bromine is orange in color. All right, that's a very powerful statement. The species on the right hand side of the equation are colorless, which means this is colored and the entire thing is colorless, right? The entire thing. This is colorless and this is colored. Changes are made to three separate portions of the equilibrium mixture, which row shows how the color of the mixture changes when a small amount of each substance is added. Okay. When you add sulfuric acid, remember guys, when you add sulfuric acid, because of ionization of H2SO4 solution, because of ionization of H2SO4, I'll get hydrogen ions and a sulfate ions. So when these hydrogen ions are involved in this equilibrium mixture, obviously this increases the concentration of hydrogen ions. And if this increases the concentration of hydrogen ions, according to Le-Chatelier's principle, equilibrium favors towards left-hand side. If equilibrium favors towards left-hand side, obviously aqueous bromine forms immediately, and that means the orange going to be more darker. So darker orange as the equilibrium favors towards left-hand side. So option D is incorrect. What happened when we add solid sodium bromide? When we are adding sodium bromide, obviously we are adding sodium ions and bromide ions in the solution. And these bromide ions increases the concentration again in the solution. And so equilibrium favors towards left-hand side. And therefore, aqueous bromine becomes darker. Option C is incorrect. Adding water. So when we add water into this equilibrium mixture, obviously this favors the equilibrium towards right-hand side. If this favors the equilibrium towards right-hand side, solution turns to colorless, right? Or from darker to paler orange, right? Oh, from darker to paler orange. There is no colorless option is given, which means I'll go for the paler orange, not darker. So I believe B is going to be the right answer, okay? That's a very, very important information regarding Le-Chatelier's principle. Let me repeat one more time so that you will get the idea. When we add sulfuric acid in this mixture, this increases the concentration of hydrogen ions. And according to Le-Chatelier's principle, equilibrium favors towards left-hand side. That means aqueous bromine is going to be dark orange, right? When we add sodium bromide, this increases the concentration of bromide ions, favors the equilibrium towards left-hand side, and obviously aqueous bromine becomes more darker. When we add water, this shows that the position of equilibrium towards right-hand side. And obviously, there is a change in color. Obviously, it's going to be lighter from darker orange, all right? So I'll go over paler orange. Therefore, B is going to be the right answer. Question number 19, guys. In which substance does the nitrogen atom have the same oxidation number as the nitrogen atom in HNO2? First of all, let me get the oxidation state of nitrogen in HNO2. So let's suppose nitrogen is X. Hydrogen has a charge of +1. Oxygen has a charge of -2. We have two oxygen atom into 2. Since the molecule is neutral and has no overall charge, which is Y equals to 0, then X equals to +3. So technically, I need to check which option has +3 oxidation state of nitrogen. Assuming the following oxidation number for the other elements in these compounds. Hydrogen is +1, fluorine is -1, oxygen is -2. So let me check with the first option. Nitrogen is X, fluorine has a charge of -1. We have 3 of fluorine atoms into 3 equals to 0. Then X minus 3 equals to 0. Then X equals to +3. So basically A is going to be the right answer, because in A, nitrogen has the same oxidation state as HNO. All right. Question number 20. Lime water is aqueous calcium hydroxide. Lime water is aqueous calcium hydroxide. That's perfectly fine, but you should know that lime water or calcium hydroxide is basically an alkali. If it is an alkali, its pH must be greater than 7. All right. It has a pH below 7. That's incorrect, because its pH is greater than 7. It gives blue-green color in the flame test. I don't think so. Alkalis, salts can give the test. Alkalis cannot. reacts with ammonia to form ammonium salt. Basically, when it reacts with ammonium salt, then it releases ammonia. So this statement is absolutely incorrect because it is not possible. It turns yellow when methyl orange is added. That's true. In alkali, methyl orange shows yellow color. In acid, methyl orange shows red color. So D is going to be the right answer. Okay, for question number 20. Okay. Question number 21. Which two oxides will both react with aqueous sodium hydroxide? Remember, aqueous sodium hydroxide is an alkali. That means oxides must be acidic so that they can react. Acidic or amphoteric. So this is basic oxide, cannot react with calcium, cannot react with sodium hydroxide because basic oxide and alkali, they cannot react together. Okay, so option A is incorrect. B, calcium oxide is again basic oxide, cannot react with alkali. Option B is incorrect. Copper 2 oxide is basic oxide. Obviously, it cannot react with NaOH. So right answer is going to be D because sulfur dioxide is basically an acidic oxide, so it can react with NaOH. Also, zinc oxide is basically an amphoteric oxide, so it can also react with NaOH. 22. A solution of sodium carbonate is added to tap water. A white precipitate forms. Which ion present in the tap water causes the precipitation to form? So when sodium carbonate is added, obviously sodium chloride is formed in the first option. Sodium chloride is formed. Sodium chloride is soluble, right? So it's not going to form precipitate. Option A is incorrect. When sodium carbonate is added with magnesium, obviously it will turn to magnesium carbonate. And you guys know that magnesium carbonate is insoluble. So you will get the precipitate for this. So right answer is B. Let's talk about option C. Potassium, when treated with sodium carbonate, it will turn to potassium carbonate, and potassium carbonate is also a soluble salt. And sulfate, the sodium sulfate is basically also soluble, so that will not give you precipitate. So that will not give you precipitate. Potassium carbonate cannot give you precipitates, and therefore B is going to be the right answer. 23. The characteristic properties of element change from left to right across period 2 of the periodic table. On the left of the period, the charge on the ion formed by an element is the same as the group number. That statement is right, because if element found in group 1, the charge needs to be +1. If element found in group 2, the charge needs to be group 2. If element found in group 3, the charge needs to be has to be +3, right? So that's what we have done in atomic structure. You can even check in the notes, right? But if the element is found on the left-hand side, obviously it's going to be metal. And metals always forms cations, which are positively charged ions. They cannot form negative ions, which means only first statement is correct, and therefore B is going to be the right answer. Question number 24. Which statement about group 7 halogen is correct? Group 7 halogen. Bromine consists of Br2 molecule at room temperature and pressure. That's correct. That's a very sensible statement. Let me check other options. Iodine will displace bromine. That's not even possible because the reactivity of iodine is lower than that of bromine. So that's not possible. The halogen becomes darker in color. That's right. Because the relative molecular mass decreases. Actually, the relative molecular mass increases. That's not decreases, that's actually increases. And since C also incorrect, the halogen becomes more volatile. Uh, More volatile. So I think less volatile because iodine and astatine both are solid at room temperature and pressure, which means they cannot evaporate at RTP, which means volatility decreases down the group, right? So option D is also incorrect. And therefore A is going to be the right answer. 25. A power cable requires an element that conducts electricity, has a relatively low density, is ductile. Which of these properties does aluminum have? Aluminum conducts electricity because it contains maximum valence electrons. Has a relatively low density. That's right. Is ductile. That's also right. I believe A is going to be the right answer. All right. Oh, next is 26. Which diagram represents the structure of an alloy? Alloy is a mixture of metal, also non-metal with carbon. So B is going to be the right answer because B is basically graphite because graphite has a layer structure. That's incorrect. C is diamond because diamond has tetrahedral arrangement. That's incorrect. A is basically metal. So, and B is basically alloy because it exhibits mixture of different metals because they have different sizes, right? Most metals react with oxygen in the air to form a metal oxide. Which metal form a metal oxide layer that reduces its reactivity? We have aluminum, copper, iron, and silver. And according to the reactivity series, aluminum is most reactive. Then we have iron. Then we have copper. And then we have silver. So this is least reactive. And this one is more reactive. So more reactive metal can easily react with oxygen to form thick oxide layer. And after the formation of this thick oxide layer, aluminum cannot react with oxygen, and that reduces its apparent reactivity. All right, so I believe A is going to be the right answer. Question number 28. Which statement about corrosion of metal is correct? A barrier method is needed to prevent the corrosion of stainless steel. By the way, stainless steel is an alloy, and this alloy do not corrode, and therefore A is incorrect. Okay, and what is barrier method? Barrier method is a method in which an object is coated with oil, grease, or paint or plastic. That's the barrier method. Okay, so if an object is surrounded by oil or grease or paint or plastic, that's called barrier method. And you know that stainless steel is an alloy, and alloy cannot corrode. In fact, stainless steel do not corrode at all, which means option is incorrect. Next is iron corrode to produce hydrated iron 1 oxide. When iron corrodes, it's basically converted into iron 3 oxide. So that's iron 1 oxide, which is not possible. That's iron 3 oxide. That's rust basically. Okay. Option B is incorrect. Sacrificial protection uses a less reactive metal. Guys, it needs to be more reactive metal. So that the more reactive metal sacrifices itself and it protects the metal object. All right. So option C is incorrect. Consequently, D is going to be the right answer. When corrosion occurs, the metal loses electron to become positive ions. That's right. So 28D. Let's talk about 29. Some metals and the compounds in their ores are shown. Which type of reaction occurs in the extraction of these metals from its ore? In order to extract, these are the ore, and we need to extract these elements, right? By using these ores. So aluminum oxide, in aluminum oxide, aluminum has 3 plus charge. So it will gain 3 electron and convert it into aluminum. In calcium carbonate, calcium has 2 plus charge. It will gain 2 electron and will turn to calcium metal. In PBS, lead has 2 plus charge. It will gain electron and convert it into lead metal, right? So going from here to there is basically the gain of electron, and gain of electron is technically reduction, and therefore D is going to be the right answer. Okay. And I have told you in the class that whenever you need to extract any metal from its ore, we need to go for reduction process. Reduction takes place either with carbon, reduction takes place either with hydrogen. All right. That's what we have done in the syllabus. For 30, which statement about natural sources of water and the domestic water supply is correct? Chlorine is used to remove taste. Chlorine not. In fact, charcoal. Option A is incorrect. B. Metal compounds from detergents can deoxygenate natural sources of supply. That's not even possible, because metal carbonates, let's suppose we have metal carbonate, which has a formula of MCO3. Now, in this MCO3, metal has an oxidation state of 2 plus. Exist in its highest oxidation state already. That means it cannot further oxidize. Okay. C. Photosynthesis provides oxygen needed for aquatic life in natural sources of water. That's true, because photosynthesis is a process in which glucose and oxygen gas are formed, and this oxygen gas is used for aquatic life in natural sources of water. So I believe C is a sensible statement. C is going to be the right answer. Last option. Sedimentation removes nitrates. By the way, sedimentation is a process in which we need to remove insoluble particles or insoluble substances, whereas nitrates are soluble. So for soluble substances, we cannot use sedimentation, and so D is incorrect. 31. Gases that may be present in air are listed. Okay. Which gases are atmospheric pollutant? Obviously, carbon monoxide is an atmospheric pollutant because it is a poisonous gas. It combines with hemoglobin so that carboxyhemoglobin is formed. And because of the formation of carboxyhemoglobin, hemoglobin is no longer available for the transportation of oxygen in different parts of the body, which means it is a poisonous gas. That's a whole process actually. Methane is a greenhouse gas, causes global warming. So 2 and 4, I believe C is going to be the right answer. Question 32. Which compound are in the same homologous series? Guys, you have to be very, very expert in such areas, because you guys should know what sort of compound has already written there. So this is basically an alkane. Now this compound has double bond, so between the carbon atoms, so it is an alkene. So obviously examiner is looking for the same homologous series. So one is alkane, one is alkene, so they are not belong to the same homologous series, and therefore option A is incorrect. Next is, this is alkene because double bond is present between these two carbon, which are highlighted ones. This is also alkene because double bond is present between the carbon atom, highlighted carbon atom, and this is also alkene because double bond exists between the highlighted carbon atom. CH3, CH double bond, CH2, CH3, CH2, CH double bond, CH2. So I believe B is going to be the right answer because all of them are alkenes. So they have this, so they will belong to the same homologous series. All right. Whew. All right. Option C. Let's talk about option C. This is OH, which means it is an alcohol. This is also OH, which means it is an alcohol. This is COH, which means this is carboxylic acid. The carboxylic acid and alcohols are different homologous series, and so option C is incorrect. Again, this is alkane. This is also alkane. And this has alkene because the highlighted carbon atom has double bond between them, right? So obviously it's not true because alkane and alkene both are different homologous series. Both are belong to different homologous series. Question number 33. The diagram shows core structure of C4H10, C4H8. That's what we have done in isomerism. I have told you about the different structures of C4H8 in alkene chapter, right? In under the heading of isomerism. So you guys need to revise that thing. So first of all, this is CH3. Then we have CH2. Then we have CH. Then we have CH2, double bonded CH2. So that's the first one. Okay. Let's talk about the second one. We have CH2, double bond, C. This is CH3, and this is CH3. Right? This is CH3 here, CH2 here, CH here, double bond here, and this is CH2 here. Again, this is CH2, this one, double bonded carbon, this one. This is CH3, this is CH3, this is CH3, this is CH3. Let's talk about the third one. This is CH3. This is CH, double bond, this is CH, and then CH3. Fourth one. We need to find the same molecule, right? That means the structure needs to be same. So let's talk about the fourth one now. Fourth one has CH3. Then we have carbon. Then we have CH3. Then we have double bond. And then we have CH2. So this CH3, carbon and CH3, that's the same. Double bonded carbon atom and then CH2, double bonded carbon atom and then CH2. So I think this and this structure is same. 2 and 4th structure are same, and therefore D is going to be the right answer. Okay. Question 34. The displaced formulae of 2 organic compounds are shown. By the way, this one is an alcohol. This compound belongs to alcohol homologous series, whereas this compound belongs to ester. And what I've told you in the class, esters are of 2 types, in which first one is in which we have 2 alkyl groups, right? Attached to the functional groups. And the other one is we have hydrogen and an alkyl group on the other side. So examiner has given this one. What are the name of this compound? See, this is 1 carbon alcohol, which means it is methanol. Obviously, these 2 options are incorrect. This is going to be ethyl. This is going to be methanoate. So it's ethyl methanoate. So ethyl methanoate is here. Ethyl methanoate is here. then obviously C is going to be the right answer. Okay. Remember one thing. Let me explain it again. This is ethyl and this is methanoate. So technically it is ethyl methanoate. Okay. Two products of the separation of petroleum are the lubricating oil fraction and the kerosene or paraffin fraction. Which statement is correct? The lubricating oil fraction is more viscous than the kerosene paraffin oil fraction. That's true because lubricating oil fraction has more carbon atom than kerosene or paraffin fraction. Okay, that's true. You can even write lubricating oil has larger hydrocarbon chain, or you can say more number of carbon atoms. Which means it has higher MR, which means it is less volatile. Okay. Which means it has higher boiling point. So let's talk about other options here. The lubricating oil fraction is more volatile. No, it is less. It is less volatile. Option B is incorrect. The lubricating oil fraction has lower boiling point, higher boiling point. Option D, molecules in the lubricating oil fraction have a smaller chain. This one, it needs to be larger chain, bigger chain, because it has more number of carbon atoms. So option D is incorrect. Okay. 36. An incomplete equation for the reaction of propane with chlorine is shown. So when we have when this reaction takes place, by the way, this reaction takes place in the presence of sunlight or UV light or ultraviolet light is the same thing. So activation energy for this reaction is provided by ultraviolet light. That's true. Next, C3H7Cl has two different structural formula. That's also true. How come? We have 3 carbon atoms. Draw them. In the first one, let's suppose chlorine is attached to this carbon atom. In the second situation, let's suppose chlorine is attached to this carbon. So both of them have same molecular formula, but both of them have different structures because in the first structure, chlorine is attached to the first carbon, whereas in this structure, chlorine is attached to the second carbon atom. So it's basically one chloropropane, and it's basically 2 chloropropane. All right. So this compound has 2 different structural formulas. That means it is correct. By the way, whenever this reaction takes place, always HCl gas is given off, which is an acidic gas. The third statement is also correct, and therefore A is going to be the right answer. 37. Glycerol is an alcohol with 3 OH groups as per molecule. What is the equation for the combustion of glucose? Glycerol, sorry. Ouch. So how many carbon atom? 1, 2, 3. How many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8. And we have 3 oxygen. Let's talk about the combustion now. You will get carbon dioxide and you will get water. Balance the carbon atom. We have 3. We have 8 hydrogen. We have 8 hydrogen. let's talk about the oxygen atom. 3 times 2, 6. 6 plus 4, 10. 6 plus 4, 10. So we have 10 oxygen here. So we have already 3. So to make 10, how much oxygen we needed here? We need 7/2. And 7/2 is basically this 2 and 2 cancel out with each other. So we have 7 oxygen here, 3 oxygen here, to total 10 oxygen. But examiner has not written any option like this, which means we need to multiply the entire equation by 2. Multiply by 2, you will get, hold on, 7.2 divided by 7, 3.5. So basically this is 3.5, right? So when we multiply by 2, it's basically 2C3H8O3 plus 7O2 arrow 6CO2 plus 8H2O. Check this equation. This is incorrect because hydrogen cannot produce or cannot form. This is incorrect also because it has different, it has a wrong molecular formula. So option B and option D are incorrect. A competition exists between A and C. In this, oxygen is not balanced, which is why option A is incorrect, and therefore C is going to be the right answer, because that's what we have done, exactly the same equation given in the option, right? 38. Compound X decolorizes acidified aqueous potassium magnate 7. Compound X has the empirical formula C2H5O. Some possible structure of X are shown below. So, okay, empirical formula. So this compound has 2 carbon, 1, 2, 2 carbon, 1, 2, 3, 4, 5, 6 hydrogen, and 1 oxygen. So this is the molecular formula, and the molecular formula is exactly and if we halve it, we cannot halve this formula because we have only 1 oxygen atom, right? So this cannot be the right answer because cannot get the empirical formula from this structure, right? Or from this formula. So that's not possible. In 2, we have 1, 2, 3, 4 carbon atom. Count hydrogen now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogen atoms. How many oxygens now? 1 and 2. Now this is the molecular formula. Half this molecular formula, you will get the empirical formula. That it means if you half it, you will get C2H5O. That's exactly the same, which means second statement is right. Second structure is right because we are getting the same empirical formula from it, right? Let's talk about third one. 1, 2, 3, 4. Let's count hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I believe 2 oxygen atom, 1 and 2. So if you halve this molecular formula, you will get the empirical formula. So that's also right. Fourth, 1, 2, 3, 4 carbon atom. Count hydrogen. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 hydrogen atom. We have 2 oxygen atom. If we halve this, we'll get C2H4O. And that's not the formula. Empirical formula given by the examiner. Examiner has given C2H5O, whereas we are getting C2H4O. So number of hydrogen atoms are not balanced, right? Which means fourth is also wrong. Only 2 and 3 options are correct, and therefore C is going to be the right answer. Question number 39. Which statement is correct? A filtrate is left on the filter paper. Left on the filter paper, not filtrate. Residue is left on the filter paper always. That's wrong. A saturated solution contains only substances with single bond. Saturated solution doesn't always contain single covalent bond or single bond. Saturated solution are those which are highly soluble in water, and not necessarily they should contain a single covalent bond or single bond. That statement is incorrect. Only that statement is wrong, because some ionic compounds like copper sulfate, like sodium chloride, like lead bromide, like sodium magnesium sulfate. So I can make the saturated solution for such compounds as well, and these compounds doesn't have any single bond, so not possible. Solute is a substance that dissolves a solvent, that dissolves in a solvent. So that statement is also right, incorrect, and therefore D is going to be the right answer, because solution can never be described as pure, because solution might contain multiple products, like when we make when let's talk about NaCl and silver nitrate. They will react together, converting into silver chloride and sodium nitrate. There are two different substances, right? And they're not pure. So solution can never be described as pure. Solution contain one or more than one product or one substance. 40, last question. A student does two experiments. In experiment 1, ammonium carbonate is reacted with dilute hydrochloric acid. So when ammonium carbonate is reacted with dilute hydrochloric acid, obviously you will get ammonium chloride, carbon dioxide, and water. It is an acidic gas. Also, it is water soluble. So you will get acidic solution. So it changes color from red, from blue to red. From blue litmus paper into red. My bad. That's a lot. Okay. So this is your dilute hydrochloric acid. This is your ammonium carbonate. You have damp red litmus paper. You have damp blue litmus paper. Obviously, it is an acidic gas. So cannot change damp red litmus blue, but changes blue litmus paper into red. So that's right. Now we have another experiment. In experiment 2, ammonium carbonate is heated with aqueous sodium hydroxide. So that's the very, very famous statement, famous experiment. We have done so many times, even in the papers, inside the classroom also. We have ammonium carbonate. When we add sodium hydroxide in it, and we heat the mixture, obviously we'll get sodium carbonate and ammonia gas. Okay, so when any ammonium salt react with any alkali, then always salt, water, and ammonia gas is given, right? And water. Since ammonia is an alkaline gas, so it changes damp red litmus into blue. In experiment 1, it's going to be red. In experiment 2, it's going to be blue. So I believe C is going to be the right answer.